Okay. All right. I'm going to give an update on ArduPilot's object avoidance. Here's the agenda. One thing I guess to understand or to make clear at the beginning is that there's two types of object avoidance at least, or two solutions. So there's an onboard solution and then an offboard solution. And I'm going to talk about both of these approaches. They're kind of proceeding in parallel. So first of all, I'll talk a little bit about the existing onboard solutions that we have and some of the problems that we have in those solutions. Then next, I'll talk about something that we've been working on a lot recently, which is the offboard solution using ROS. And again, talk about some of the issues that we have in that area. And then finally, I'll come back to the onboard solutions and talk about the difficult next steps that we want to make. This little viewer at the bottom is just a picture here. It's the proximity viewer from Mission Planner. So if your 360 LiDAR is working, you'll get a view like that. It's not related to too much. So one of the existing solutions that we have for rover is called dodge avoidance. It's been there for a long time, for many, many years. It's a very simple approach to try and avoid objects. Basically, you've got a forward-facing LiDAR. If it sees something, it will turn left or right for a certain amount of time to try and get around it. It's not sophisticated. It only really works in very specific situations, in particular the AVC challenge, the SparkFun AVC challenge, where there'd be a big barrel in the middle of the lane. The dodge method would work for that. It would, if there's a big barrel in front, it might possibly turn for a second or two to get around it. It's not a good general purpose solution, but we have that. The other solution that we have is really stopping before you hit objects. And this is a sensor-based approach, which means that we just take the data from either the one-dimensional LiDAR or the 360 LiDAR, and we build a little fence around the vehicle. Out of the flight modes, at some level you usually get a velocity, a desired velocity coming out of one of the upper controllers. Either it could be the pilot, it could be the autopilot. You end up with this velocity vector of where you're trying to go. And we compare that to that vector. We compare that and see where it hits the miniature fence. And if we have to, we shorten the vector. And that way the vehicle tends to slow down before it hits the object. It doesn't help you hit the object. Copter, by the way, this same feature works on both rover and copter. Copter also has the ability to slide around objects, but it only slides a little bit. So if your vector kind of hits the wall like this, at an angle, it will slightly divert the vector. And so if you push hard enough, and if you try hard enough, long enough, the vehicle might slide past the object. But it's not any kind of sophisticated, path planning around the object. Is that clear? Yeah. Just interrupt any time if you have questions. We actually have an ignore angle. We have a set of ignore parameters. So you can, if you have to, you can set up little angles to ignore legs or antenna on the vehicle. Most LiDAR, like the A3, the RP LiDAR A2 or A3, actually just won't even register things which are really, really close. They'll just ignore anything that's less than 50 centimeters away. So here's an example. This is quite an old example now. So this is a quadcopter from Lightware mounted on the bottom, 360 LiDAR, the hedge, or hits the hedge. It works pretty well. Then if you want to see the same thing on a rover, this is my Ion Robotics rover. It's in acro mode, and I'm trying as hard as I can to make the vehicle hit those little wooden blocks there, and it stops. And then here, slightly, and once the velocity vector, the rover can get around. Right, it gets around, no problem. Yeah, let me just grab a little water here to keep my...
Clearly, that black one rover didn't have it yesterday when it keeps except that was a malicious attack.
Oh.
That was using comedy.
Yeah.
Yeah, so here's the vehicle here. It's an Ion Robotics rover, which is my personal favorite. So there's a lot of problems with these, well, not a huge number of problems. There's a few problems with our current solutions, onboard solutions. One issue is that it's sensor-based, and that means that it really has no memory. It just uses the current information that it's got from the sensor as the basis for building up that little miniature fence. And that means that if there's a sensor error, say, for example, it doesn't return a distance in one direction, the vehicle might get a little bit too close to the object. That's clear? So in the future, what we want to do is we want to, maybe store the fence for a few seconds. So maybe we'll keep a little collection of 10 fences, the last 10 fences that we've seen, store them away, and then use the closest one instead of just the latest one. One other issue that we have is the miniature fences and body frame. So essentially, it's building up a little fence. It's like a hula hoop around the vehicle, and as it's running forward, the hula hoop is moving with the vehicle. So that's not so great because it means otherwise, again, you might not stop in time, right? So quite an easy solution to that is actually stored in earth frame. So you instead of storing the distance from the vehicle, you store like a whole bunch of lat long points or offsets, from the EKF origin. Yeah. Another small issue, the vehicle currently will not back away from an object. So again, if you have a sensor error and it gets too close, the vehicle won't back away. So we'd like to fix that. Also, this simple stopping behavior is implemented in rover in auto mode, but it's not implemented in copter yet. It's actually very easy to implement it in copter. We can just hitch it into the position controller so that it does stop before it hits things. So it's not a difficult task. I'm just concerned that the vehicle gets stuck behind things. So you're trying to do an RTL or something, and you have a sensor error, for example, or some other reason, the vehicle might just get stuck behind. So that's why we haven't enabled it for copter, but a lot of people have asked for it. My thought is that we will enable it for copter when we get at least some slightly more advanced path planning included. Okay, next one is the off-board solution that we've been working on. So this is the SystemVue. So what we have on the bottom is ArduPilot. So in those previous examples, the onboard solution, the RP LiDAR, the 360 LiDAR, which is the black, been directly connected to the flight controller. In this solution, instead, we connect the NVIDIA TX2, but you could use something else. So that feeds all of its data into this RP LiDAR node. That then feeds all the data. The cartographer is responsible. And then that map is also passed to something called the base local planner in ROS, which is a path planner. So, and all three of them are then providing data down into ArduPilot. So even though directly connected to the flight controller, we're using an obstacle distance Mavlink message to get that same data down into ArduPilot. So that all goes down, and then we feed that into the proximity library in ArduPilot, and then ArduPilot still will do all of its onboard object avoidance, just as if the LiDAR was directly connected to the flight controller. Cartographer SLAM, like I said, it provides a position estimate, a local position estimate. We can now feed that into the EKF, thanks to Paul's work. Only the EKF2 at this moment, but it can provide that. So again, we can use that in place of GPS. And then we have the base local planner, which is the path planner. And what we've recently added is the ability for ArduPilot to pass back a position target into that base local planner. So up until now, you've always had to use like a ROS tool, like RViz, RVIZ, to provide the position target. But recently, we've made it so that ArduPilot can pass that position target up. So this allows you to do cool things like pull up Mission Planner, click on the map, and say go to here, and it will use ROS's path planner to get you there.
So can it do the same thing with if you have an auto mission plan?
Yes.
Yes,
exactly. So in both cases, yes, ArduPilot, either whether the position is provided through the user clicking on the map, or if it comes out of a mission command, ArduPilot can pass that back up to ROS. And then ROS provides low-level velocity commands. Oh, I'm envious. Yes, I'll take that. Wait. Oh, okay. I was lucky. Yeah, ROS will provide low-level velocity commands down into ArduPilot. And for those of you who aren't super familiar with guided mode, ArduPilot's guided mode accepts lots of different velocity commands, lean angle commands. Guided mode can do all these things. So velocity commands into ArduPilot's guided mode, and then ArduPilot takes care of executing those commands. Is that clear? Yeah. And yes.
Only the next waypoint gives it, or does it give it a sequence of upcoming waypoints for the path planner?
It only gives you the next one. So sorry, and sorry to add confusion, but we use, like I said, guided mode accepts lots of different commands, position commands, velocity commands. Recently in auto. So you can have an auto mission, and then you can use a guided enable command to essentially shove you over into guided mode for a moment and then come back, if that's clear. Well, and essentially, when it's executing these special guided enabled mission commands, it accepts commands from an external system.
So all you're really doing is injecting a new waypoint to take it off its auto path and then release it back to the website.
Yes. Yeah. So if you want to see this in action.
I have a question about that. I was going to add stick mixing to the broker, and it seems like it's almost better to do that. Like if you're in auto, like does it with an object front end. Almost not guided.
You could. Yep. So this is what I just described. This is a little video. There's no sound on this one. So this is the case where I've used Mission Planner. I've created a couple of commands at the bottom. It's a very new command, so it's guided enable. This wasn't available. So you have to use the unknown command, but it'll be set the command type to guided enabled. And then your PC locks up. Yeah. Sorry, we'll edit this part out of the video.
That's an idea, really.
Just think about it, like, if you're talking about blue screen,
Oh, it's back. Here it is. Sorry, it recovered.
I thought section like a robot. Yeah.
It's a great robot. Okay, it recovered. Great. Huh. Oh, there it goes. Wait. I'm going to skip forward. It seems to be maybe having a problem with a certain part of the video. Here we go. So, or maybe just a very heavy video. Yeah, so it's split screen here. You can see the RViz view on the top. This is essentially this is where we'll go, this little green path here. Right, and down here is the Mission Planner view, so you can see, the vehicle in real time. Yeah, there it is, and there's a little rover. maybe you missed it, back past that barrier and then came back. It's on my YouTube channel.
Subscribe to the next exciting video.
Yeah. There we go. Now it's working. I don't know.
I'll update right on that. So there'll be a velocity limitation you kind of can't exceed because Ross won't keep up.
Yeah, so I think in this example, Ross was sending velocity messages at like 3 or 5 hertz. Not very fast, but not too bad. Sorry, okay, maybe it'll work. Well, okay, well, you know, essentially the vehicle, in this video, the vehicle rolls up, it circles here a little bit, and then it goes around, then it turns around, and then whatever.
Does the mission plan, if you just keep the original straight line thing, or does it?
Yeah, the mission.
Does it aim on?
So in this mode, from ArduPilot's point of view, it only has velocity commands. So I'm not sure if the mission planner will show anything.
It'll just go off track and come back.
Yeah, it doesn't. And currently, where it's going is not even shown on the mission planner. But I think that that's just a display issue. I think mission planner could show where it's trying to get to, but it wouldn't show the path because it doesn't know anything about it. Yep.
That's the video that's doing the dance.
Yep. So yes, a bunch of issues. Actually, I'll get to that in a second. But basically, this is very new. I'm not a ROS expert. There's a bunch of ROS configurations that I don't know anything about, and one of them is called the it's the response option, or the response configuration when you are about to hit something. And in the way that I have it, continuing. So if it gets too close to anything, it does a little circle. That's configurable on the ROS side. So I've been working a lot with Hamey from Ion Robotics, and he's got a test. In his test, he set up a mission the same way. It's got like 4 waypoints in this area. It's best to look at the right side of the screen, actually, over here. It's very slow. But on the right-hand side, it's a little more interesting. You can see the little rover on the screen right here, and it's way around the area. Waypoints if they're hitting anything.
The dark light blue is where it's constantly seeing object, and the light dark blue where it's
I think this is coming from the local base planner. I'm not an expert on this side. I think it's probably like, I'd like to try and avoid the blue area if possible. The red is where I definitely should not go. I believe that's what it is. I think it's yeah. I think the blue area is sort of danger areas near solid objects.
it's sort of range bands from it.
Yeah.
An object. So the light blue object.
It's kind of an example because you have a point blank on them right there.
Yeah. Yeah.
This was actually taken a couple days ago in the NVIDIA GTC conference. And the video is bad because there's like 10,000 Wi-Fi access points right there.
Yeah. But again, you can see it's making a little path here to get around. Also, Hamey's taking the extra step of adding a Intel RealSense camera on the front to add additional barrier information. So if you see these little squares that are showing up around people's legs and things, that's yeah. Anyway, that's
Just remain that in the video.
yeah.
Start showing the legacy objects as well, because the universe is moving around and what was originally seen with the future.
Yeah, I think it forgets after a while, but I'm not sure.
Yeah, there's a roof that's right. So it's intentional.
You see the top start to creep in as systems lane.
So on that map on the right side, basically it sees things
I've never tried putting it in a box to see what it will do, but I suspect it will just keep on trying and circling now and then, trying to find a way out forever. Yeah.
I think we're actually running autonomous right now. It does a few times in conferences, and it's actually in a wander mode. So it just drives around and avoids people in this conference. Like, normally in a conference on a demo like that, it's actually by itself just with rock and avoiding people.
Yeah.
Conference, let people go ahead and do it, push it around and all that kind of move away.
That's kind of like open people now as well.
Yeah. It's people feel like every single person there is like an NVIDIA, their graphics and things, so they want to like test it constantly, right?
Yeah.
It's funny because you just like go around the crowd, whatever.
Yeah. So there's a bunch of things, sort of a new world opens up when you make a good interface between, ArduPilot and ROS. So there's like the wander behavior in ROS, but Hammy told me in this case that he set up a little mission like this, and that it's trying to get through those waypoints. That's what he told me at least.
There's very much thought about ROS too.
Thought about it slightly, but not really much, not yet. Is that clear? Questions now? So a bunch of issues that we have with the ROS integration right now, and things that we want to do. Beginning behavior that you saw in my video, Hamy's videos does not have that issue, so I can just talk to Hamy hopefully, and we can sort out and consolidate our ROS configuration so that it behaves better. Another thing that we'd like to do is get it working for multi-coppers. Pretty much as soon as I uploaded that video of the rover rolling around and not hitting the barriers, I got 2 questions saying, oh, can we use this for multi-coppers as well? And I think the answer is yes. We'll probably need to make Cartographer run in 3D mode instead of 2D mode. And also, we may need to use a different path planner, a 3D path planner instead of the 2D path planner that we used in the rover. Maybe with S-curves, I don't know.
You're doing something else.
We're working on 3D path planning in bottom map and either using single mono camera or stereos. We have the old Intel, the B435, and we ordered the new one. We're probably going to combine those two.
Yeah.
And we also are using 3D cameras facing 120 degrees from each other to have a 360 degree
Yeah.
view. So we're working on those 3 things that roll out. So next couple of months we'll probably produce something nice.
That sounds great. So for those who couldn't hear, Amilcar, a 3D solution, a couple steps ahead of us perhaps. So one of the things I'd like to add actually, I'm really encouraged to hear that from Amilcar. One thing that I've noticed when working with ROS is that people are sometimes very secretive about their setups and their configuration. The setup is quite complicated. So I really encourage people to share. We have a Vision Projects Gitter chat in the ArduPilot Gitter area. So if you're using ROS and you've solved some of these problems that I'm talking about, please come and tell us. Please come and share so that we can all benefit.
This integrates with smart RTL, so it's got its own good routes, and then when wander mode something gets in the way on the way back to the base.
Yeah. Yeah, so the question there again, if people couldn't hear it, was could we use this in Smart RTL? So when the vehicle is trying to return home and then it finds itself in front of a tree, it can't get past the tree. Could we somehow use this? So that gets us down to the very here. So one option that we'd like to put in there is maybe an obstacle failsafe. So we rely mostly perhaps on the onboard object avoidance to stop before we hit things. But then if we get stuck there for too long, maybe we hand off to an off-board controller to get us around that object, and then we retake control. That's one idea. I don't know. It would be it'd be like a real fail-safe. It wouldn't be like the best behavior you could ask for because it's going to get really close to the object and then stop. Whereas if you had full information of the environment or better information of the environment, you would drive around the object as you start approaching it instead of like stopping right in front of it.
Yeah, but you get the information higher.
Yep.
It's believable and going through it much nicer.
Yep. So right, exactly. And so one of the other issues of this off-board solution is that it doesn't know about all the other things ArduPilot knows about. it doesn't know about fences, it doesn't know about stay-out zones, it doesn't know about terrain. So I suspect that these off-board solutions are great for some situations, but if we can get it on board, it'll be better because we have more information and we can integrate better with the rest of ArduPilot. So that gets us back to the, back to the onboard hard next steps. So there's a bunch of people here from Canberra UAV, and probably a lot of other people have seen this video. But if you haven't, there's a little link at the bottom of the slide.
Live demo of it here if you want to show it.
Maybe right after the chat. I'm running out of time, but yeah, yep. I definitely encourage people to watch it because it's really impressive. So this is, again, I feel bad explaining it because it's really other people's work that I don't know a lot about, but it's great work by Canberra UAV to get a plane through a very obstacle-rich environment. There are stay-out zones, there are birds, there are planes, there's all kinds. The plane does weave its way through, constantly avoiding things and gets there. So I really think this is, we need to get this into master, and we also rover and copter. So there's a bunch of challenges. Yep. Okay. Awesome. That'd be great. This is such a big area, and it's a really hard area. So really great to hear this. Other people are going to pitch in. So I just want to compare, a little bit about what I understand about Canberra UAV solution to the dodge method that we talked about earlier. The dodge method, right? We just kind of swerve out of the way and hope to miss the object. I think what the Canberra UAV solution does is it actually has a target, something in the way of the vehicle getting to that target. So then the vehicle, instead of just driving straight, drives toward. The control stack is untouched. So that solution works for plane. It might work or it might not work for copter and rover. We have a whole bunch of different modes, of course, in all the vehicles. We have lots of different modes. Those different modes take different inputs. So some of them take position inputs, like auto mode, right? But other modes, like guided mode perhaps, or loiter mode, they have velocities that they use. So we might need to come up with multiple solutions, multiple ways to get around this object. For example, if you're using a velocity controller, something. If it's a position that you're trying to get to, maybe the existing solution from Canberra UAV will work. But anyway, that's something that we need to think about and work on. Okay. This is my idea. So here we're now getting to very hypothetical, future work. This is my idea of maybe how we could integrate this. So already we have this AC avoid library. This is the one that the flight mode code calls and says, hey, I've got this velocity vector that I want, that this desired velocity vector. Is it okay? And all the other, barrier information that it has, it compares that and then returns a perhaps shortened. I think we keep that same structure in place. Maybe we have to add a new path planner library, or maybe we just integrate the path planner into AC avoidance. I'm not sure, but so then it maybe provides a new velocity vector or a new position. Sorry, it's historical. Yeah, it started off with it being implemented only for copter. Now it's used in rover as well. We could rename it.
Yeah.
Sure. Okay.
Yeah, and planes using it. Yeah. So.
Okay. Awesome. There's a couple other things we should do. We should add in more information like feeding in stay out. We now have mavlink messages which can provide stay out zones to the vehicle. We can store those on the vehicle and provide them to the avoidance library. I was also thinking maybe we should add in terrain object avoidance, so provide the terrain data into that library. It's a bit of a random slide, not really related to the other ones. But one of the decisions we need to make, identifying obstacles from the sensor. should we use a occupancy grid or should we use a obstacle list? So if you've got 360 log over there, should we maintain those obstacles in a grid or in a list of objects? So I think it should be, we're tending towards a list of objects. Yes. Okay, great. Sounds like
the automat, the way that the grids are implemented is not grid. That's really the storage, the way that it's stored is such that it's minimizing the amount of data that you need to represent the obstacle. So it allows you to represent these sparse things in a very efficient way. So if you choose the grid and you can share the code between rovers that are only 2D and copters and planes that actually need 3D stuff, because
Yeah.
the automat allows you to do exactly that, the 3D representation of the object.
Yeah. So Peter and I poked away at this a little bit, actually. The obstacle grid, occupancy grid method. It was pretty hard. And then I talked to Leonard, and Leonard suggested that we go this way. So I think sounds like consensus here is that we should go this way. So
Isn't the grid easier to test that?
that's what I was thinking. That with a grid, it's quite easy to look forward and say, hey, is that space occupied or not? Maybe that's more of an interface though than anything else.
We do lists with path planning.
Yeah.
UAV is perfectly doable.
Cool. And maybe there's even already this kind of obstacle list in CUAV solution.
Yeah.
Awesome.
Yeah. So we have multiple lists of different types of objects.
Yeah.
And it'll do path planning with priorities.
Yeah. So that would sort of get us back to this, where you might have perhaps obstacle lists from, different things, stay-out zones or terrain or something. Yeah.
I like the optical list, and most of our leverage are using the optical list method. But when arguing for the occupancy grid method is a fixed size.
Yep.
So optical list grid right now, it limits itself for memory.
Yeah, but it's not as compact.
Right.
You can actually do more with
The list and kind of integrate the occupancy grid.
Yeah.
Something like that.
Yeah. Yeah.
We get around that by pruning the furthest away objects out of the list. To limit the size.
Yes, so I'm just saying that it's because you've done the size, you can combine that on the occupancy grid, fixed size.
Yeah.
You've got to have that one.
The box representation is first you have that thing on. So it's variable size, and you have less obstacles, it's basically empty.
Yeah.
So it does not have that advantage, but it does have the advantage that it's 3D, and it does have the advantage that it's compact. Probably not as compact as the list of obstacles, but it's very compact way of representing things, and it allows you clever ways of transversing that complexity map that in a way that allows you to see if in that direction there's an obstacle or not. So it does provide a lot of advantages, and it's the standard way that it's done in broad.
Yeah.
So that's actually a downside with that. You don't want something that's scalable like that, but or dynamic. You want static as much as possible.
But this is all onboard. Let's be clear, this is all an onboard solution, so it has to fit in our flight controllers. Yeah. Yeah.
Or color.
We've run it with like 100 obstacles dynamically moving, all the velocities and things on that for no problem.
That's my question. Your obstacles have a vector to them?
Yes, they have a radius and they have their own velocity. Every obstacle has its own velocity.
And therefore application, that vector attribute, that velocity, milestone velocity vector attribute is important.
Yeah, and height. So they're 3D spheres of avoidance that are moving.
I don't mean to what you did, you keep referring to like
It's not merged yet. Yeah, but I've got a live demo of it that I'll give you in a minute.
The optical list is actually how AESB was limited.
Yeah.
Yes, there's crap everywhere.
Yeah, you don't go very fast.
But if you try to do it, try to navigate a circuit, you don't.
So one,
So that's there's a need for memory.
Yeah, it's complicated.
Yeah.
It's complicated.
I guess a couple of things to keep in mind, I guess, which is different between, or another couple of issues that we maybe will hit when we try to integrate all the Canberra UV stuff into Copter and Rover is that, of course, planes are using a very large, wide open, well, relatively wide, large open space, whereas, Copters and Rovers, in many cases, are working in much more confined areas. Are much larger for plane than for Copter and Rover.
It's been solved with voxel lines, right?
So that's on the offboard side. Hammy told me that he used something called voxel to simplify some of the sensor data down to a manageable size, even for TX2. But again, we're talking about onboard here, so
Well, your occupancy grid is the concept of voxel.
yeah,
That's what you voxel.
yeah. Yeah, absolutely. Yeah. So Grant says nothing wrong with having multiple solutions. Absolutely. Absolutely, and the regular way that we tackle problems in ArduPilot, right? We don't select one. We don't select a winner. We just, we allow parallel solutions, and then we see which one comes out on top, or maybe we just maintain 2 or 3 going forward. I was again very encouraged to hear people chipping in ideas. Area, because it's very difficult. It's a very difficult area, and it's also one of the areas that people ask me about, a couple of times a week at least. So if you are one of the people who wants to pitch in, here's a couple of ideas. Cartographer in 3D mode would be great. Sounds like Amilcar has already been working on this. Also, we have this. We produce images called AP-Sync images for commonly used companion computers. And that helps the community set up their systems more quickly instead of just doing it all from scratch every single time. We have these images which help you get going quickly. NVIDIA's come out with the Xavier, and now they come out with the Nano. So if somebody wants to come up with AP-Sync images for those, maybe including the offboard raw solutions, that'd be great. Yeah, okay. Hammy maybe has already done one yesterday or something. Okay. Okay, cool. Almost done. I hear. Okay, awesome. Some other ideas. Avoidance, feed in terrain to the AC Avoid library. So some of the simpler issues that I talked about earlier, like making rovers and Copters, to make sure that the vehicle doesn't back up too quickly. One key thing.
You might reverse LiDAR over.
Yes, yeah. Then, if you want something really hard, you can help us with the AP Path Planner library or integrating that path planning logic into AC Avoid. That would be great. And the obstacle list. So some, bringing that into master. I'm sure that's hard work, but very valuable and quite standalone. Yeah, Tom.
We combine or migrate AC Avoidance, all into a single.
Yeah. Yeah. So Tom, in case people on the video couldn't hear that, Tom suggests that there shouldn't be a separate AC Avoid and Path Planner. It should just be one library, right?
Well, AC Avoidance.
Yep.
Which is like the separate thing that's supposed to be in there. Separate.
One AP avoidance instead of AP avoidance, AC avoidance, and AP Path Planner. We shouldn't have 3. We should have 1. Yep. Sounds good. Yeah, a year ago I would have disagreed because we had the idea of, long range avoidance, avoiding, manned vehicles and things that are moving, quickly but they're very far away, and then very short range, collision avoidance. Yeah, those 2 concepts were quite separate. Maybe we can bring it together. That'd be nice. Fridge is looking skeptical. Anyway. Okay. And that's it. Oh, and finally, I just want to thank 2 of the companies that have been helping me a lot. Eames Lab, of course, my main sponsor, gives me incredible freedom, and they're also really great about sharing. So they helped me a lot with the raw setup. They helped me a lot. I really appreciate it. And also Ion Robotics. Yep. They gave me that. that very attractive rover that I use in all my tests comes from Ion Robotics, and also Hamey's been helpful as well. So thanks again to both those.